Hello and welcome to Data Engineering Explorers, and today we're going to explore Spark core concepts. So for Spark core concepts, we're going to explore the topics of its architecture. We're going to go through an overview of its architecture. Then we're going to do a deep dive on its data structures. And we're going to look into Spark as a storage engine. This is for the lakehouse format, right? The table format. So, architecture review. Spark has a goal to be a unified engine designed for large-scale distributed data processing. And its four key characteristics are speed, ease of use, modularity, and extensibility. So what does that mean? You have speed. Spark leverages the hardwares, the CPUs and its memory to do multi-threading and parallel processing of the data instead of doing it serialized. And the query computations are directed acyclical graphs. That is, you only have onwards and it's directed, and it doesn't do this, right? It doesn't go back. So you have this kind of structure. This is a simple example of what is directed acyclical graphs, DAGs, let's say. And here we have the one illustration of how the speed is leveraged. It's made, I'm sorry, and how it leverages some of the Spark concepts. So. You have the interface, the driver, the interface with the user. It's how the user is going to do. And when the interface sends a command, Spark creates an execution plan. And this execution plan, it consists of stages. And these stages consists of tasks. So the stages are operations based on a plan. Serial or parallel. So you may have a stage that comes before another stage, but when it's parallel, you have the tasks. That is the unit of execution. Actually, you can have stages parallel too, but yeah. So you have it in serial or parallel operations, and inside of each stage, you have the unit of execution, the real steps that are going to be executed per stage. And this you can see in this drawing both concepts that actually make able speed, right? The parallel processing here you can have also in the stages, as I said, the jobs, and you have the directed acyclical graphs. That it's exactly this, especially in stages, because you have stages serialized and you have stages parallel, right? So yeah. Next, you have ease of use, you have data structure abstraction. So you have the resilient distributed data sets. That's the base RDD. Just remember RDD. This is the base of the data structure for Spark. But you also have data frames and you have data sets. And this data structure abstraction makes able to be very easy to use Spark. And I'm going to go through this in the next topic, but that's basically it. And also you have simple programming model with some transformations and actions. So you can perform in, let's say, RDDs, you can perform transformations on it and actions. So you can, I have an RDD here, and I can some column of it, or I can map something. So that's quite simple command, right? And you have the transformation that, for instance, map is quite sophisticated, right? And you have also the actions, such as count. I put here count only, but you have the count. You know how many rows there are in this RDD, and etc. So it's quite straightforward. You have data structure abstraction. You can perform transformations and actions on it. You have the modularity. As I said on the first slide about this Spark core concepts, it wants to unify an engine for large-scale data. So for that, you have to have multiple programming languages. So that makes easy for the user. You don't have to learn necessarily a new data language just to use Spark. You have multiple. It is a unified library with multiple modules, such as Spark SQL. This one is the one we're going to explore the most in this course, video series, I don't know, and Python. But going back, you have Spark structured streaming for data, streaming data. You have MLlib, that's for machine learning, and GraphX. And it enables, because of that, because of having multiple programming languages and multiple modules, you enable diverse solutions, right, regarding data. And the last topic of Spark, key factors, key characteristics, is its extensibility. It decouples storage and computation, because previously what existed was Hadoop before Spark, and Hadoop couples storage and computation. So you have to use both, right? You don't have, but it was common. And as it is more interesting to have only one focus, because then you have a better tool for one specific thing. They did that, and they focus on computation, and you can use data stored in various sources. So for that, actually Spark has a lot of sources it can use. You have here some, but if you count the community plugins, you probably can use any kind of source with Spark. So you make able the extensibility of storage you can use, and you have a much better computation tool. Okay, now deep diving on data structures. You have here the same drawing about data structures, but basically you have RDDs that are more high level, and you have to set more things on RDDs. When you want, for instance, structured data, you have to you have to force, let's say, it, and then based on RDD and based on how people were using it's the data structures, they created data frames and data sets. And okay, first going to RDD concepts, and then we're going to go through the other structures concepts. RDD has three main concepts: dependencies, partitions, and compute functions. And this will make very, very understandable of why it's so simple and it's so good, the data structure. So dependencies, you have instructions to be constructed, the RDD. You have, for instance, if I have an RDD that is made with another RDD, I have this instruction. You have first this RDD1 as base, and you have this transformation. So that's the dependency that we're talking about. The RDD is constructed based on instructions. And when you're executing these instructions, you split the work to parallelize computations on the partitions. So, for instance, if you had the same situation as here, you would get the RDD1, and you would have its partitions, data partitions, 3 in this case, and you would partition the execution. So you have 3 executors for it. So you have the partitions being leveraged to be executed quicker. And last but not least, you have compute functions. So, for example, if the instruction is to change this, in the first case here, I have if x, I wanna substitute with y. So whenever in RDD1 I have the value x on column 1, I wanna substitute it with y. I will do that, right? This is the instruction of the transformation here. But in compute function, this is clearer why the partition and the dependency can be leveraged. So for each partition, you have an iterator, and this is actually the instruction for each of the partitions. And if I have, and RDDs are partitioned wisely, so if I have all of the x valued columns here in this partition, I would only have, actually I put drop here, but for the sake of the example, please think of sub, let's say sub here, but not necessarily that, but you get this part only, and you only change this one, because the instruction is specific, and you can alter just the part that makes sense to alter in this case. So here you have way less computation. You leverage the partitions, and you leverage the instructions to have less computation, and in consequence of that, less cost, less time, less processing. So that's very, very wise and very, very sophisticated. And okay, going back to the first diagram on data structures, as I said, we have extensibility, modularity, and you have multiple programming languages, and RDD is available in all of them, and so is data frames, but datasets aren't. So that's why we're not going to look into datasets, because we're going to use Python, and it is quite interesting, but it's not the focus here, so I'm not going to look into datasets. But okay, what are data frames then? If we have RDDs and they have all the awesome features that I described, why do we have data frames? Because as people who were using more Spark actually started to rise some other tools such as Pandas, and Pandas has a concept of data frame, and the data frame is basically the same thing as a relational database table. So Spark did the same. You have you already had Spark SQL, And this Spark SQL now has a data abstraction similar to the relational database table. So you have the concept of a table again here. So you can already see how does this fit with table formats. So the differences between RDD and data frames. You have RDD, that is distribution collection of elements, and you have structured and unstructured data. And data frames are a distributed collection of data organized into columns. So you have this organization into columns is the actual difference, because you have then the data concept very close to the relational data database table, and you handle well structured and semi-structured data. So data frames don't handle unstructured data, not at least before being transformed. Then you can transform it in structured, and then you can handle it with data frames. And the schema is necessary. So even if you're using semi-structure, for example, JSON, you have some columns here. You would have to create a schema saying, oh, this is column 1, and the type is int, and so on, while creating a data frame with the semi-structured data. And another key aspect is the diagram shows that the RDDs are the base for datasets and data frames, but I want to highlight that again, because data frames get decomposed into RDDs when executed. This image is from Learning Spark 2.0, a book, and you can see here how it gets decomposed. I'm not going to go through that, but because it's not the focus of the video, but I wanted to highlight that because even though our data frames can seem, let's say, better to handle data that is usually used on companies, they are based on RDDs. They are an upgrade, and when they are executed, they get decomposed on it. Okay, last concept on Spark core concepts. The concept we wanted to arrive, right, when thinking of table formats and lake houses. So how all of this relates to storage engines and lake houses. Instead of manually configuring, use a framework and leverage its features. I said this before, but we have a huge problem when it comes to data lakes handling data. And instead of handling it all by yourself, doing code for that, you can leverage Spark SQL as a storage engine and handle frameworks such as Iceberg and the other lake. And I wanted to highlight here, when thinking of data warehouses, relational databases, you have SQL and you have the relational database table. So whenever you query it, whenever you let's say alter it, insert data, whatever, you have to use SQL to do so. You have this store engine to alter your table concept. That's exactly what Spark does with open source table formats. So by having this you have a concept, a very strong concept of using ACID compliant transactions with open source data tables, data tools. This is open source because you have open source table format, you have open source compute engine, store engine. And here you would have a black box that you would have to pay a high price for it. So that's beautiful. And saying, going a bit more deep on it, you have some open source table formats. Have, as I said, Data Lake, Apache Hudi, Apache Iceberg, and you have Spark. You have Spark SQL. That's basically running Spark. If you have never seen it, running SQL inside of Spark, it's the same thing. And you have PySpark. I said PySpark because that's the tool we're going to use on next videos. And handling data frames. Data frames that are, again, abstractions of tables in databases. And the same thing here, abstractions of database tables, relational database tables. So you have both things here, open source. So if you're interested, here in the channel we have a project, an ongoing project. I'm gonna link the playlist down below, but we're going to develop a high value platform, data platform in iterations. So you deliver value quite quickly and also improve on best practices. So if you're interested, please give it a look. And if this video was helpful in any way, please give it a like, subscribe, and leave a comment if you want to. Until next time.